Hello everyone, welcome to 369 Chemistry. And in the previous video, we talked about the how the structure of atom was defined by J.J. Thomson and why it was very much necessary. Now, the next scientist was the Rutherford. What Rutherford explained about the structure of atom was Rutherford did one experiment of gold foil with an alpha particles. Okay, so there was a gold foil scattering. It is called your alpha ray scattering experiment. He bombarded those gold foils with alpha particles. So he thought that whenever the alpha particle strike the screen of the gold foil, there is a lighting emitted through it. So Rutherford was very damn sure that all those alpha particles will directly pass through the atoms because there was empty space in the atom as it was proposed by J.J. Thomson. So he was completely sure that all the alpha particles will either it will cross directly or it will be deviated by very small angles. So what he got as the result of these experiment, he found, and it was very much absurd. He saw that some of the alpha particle completely passed through the nucleus. Okay, but completely passed through the nucleus, and some were deflected by very small angles, and some were completely deflected. Like it was like when they were passing through it, it was completely coming back like 180 degree. It is coming back. So this made to him, he just postulated some of the laws by after seeing his experiment. He said that atom consists of a heavy nucleus, okay, which is the positive charge, and all the mass of the atom resides in the nucleus. Okay, basis of the observation, Rutherford concluded that atom consists of a very heavy particle, and it positively charged heavy particle, and that it is called the center or the nucleus. Okay, why positively charged? Because alpha particle was also positively charged. Since it was completely deflected, that means positive same charge repel each other, so therefore the alpha rays were completely deflected back. Okay, so he called that to be nucleus, and he said that the mass of the nucleus is equal to the number of protons and electron present in the atom. Okay, the entire mass of the atom resides in the nucleus, which is equal to the masses of your protons and neutrons, since the mass of the electron is negligible. Okay, now the volume occupied by the nucleus is very small as compared to the whole atom. Okay, and he also says that electron revolve around the nucleus in a circular manner, revolving around in a closed orbit in a circular manner. So he said that, but he could not explain one thing, that those circular orbits are regenerate or they are energy shells. This was explained by Niels Bohr, because he could not explain this. Because see, if suppose there is a positively charge in the in the nucleus, and there is a negative electrons revolving around in an orbit, we understand. But by the laws of electromagnetic waves, see, if something is revolving around the positively charged, this negatively charged electrons which are revolving will emit the radiations, and similarly it will lose energy in different subshells, and it will come and fall into the nucleus and it will be destroyed. So here he could not explain, though he could not explain the degeneracy of the atomic orbitals. That was explained by your Niels Bohr. So we will see what Niels Bohr model was. The weakness of the Rutherford was removed by Niels Bohr. He said that electrons revolve around the nucleus in a specific circular orbits, okay, and that is which is at a definite distance. Like there is a definite distance between the nucleus of the atom and the subshells. Okay, so that time we understood. Okay, so see, basically the solar system which is there in the macro level is also there inside an electron in the minute level. So just see the power of the universe, which is there in a macro level, is also there inside an atom, which is the smallest particle of the universe, right? So see here, as the electron remains in a particular orbit, it neither emits nor loses energy. Okay, so in particular energy, it will completely revolve. It will neither radiate energy or nor it will lose or gain or absorb energy. Why? Because if it does, it will go and fall into the nucleus. So that was explained by Niels Bohr. And even planets, they revolve in their orbits, but do they fall into the earth or to the sun? No. So it is degenerate. Okay, now the orbits of such a constant energy are called your stationary orbits, or the stationary energy levels, or the simple energy levels. Now different energy levels are there. Okay, so these will be different energy levels, and we will find the equation of these energy levels, and this is going to be very important, because when we go for Schrodinger wave equation, when we go for higher into study of quantum mechanics, here it will go to the minute level, and we will see the quantum theory. So here he says that different energy level has been denoted by 1 2 3 and so on, and are called your principal quantum number. So that we call as is your principal quantum number. So for those electrons which are there in the first shell, we call first electron. Then there is second shell, there is third shell, there is fourth shell, and so on, continue. So this way, when we plot the elements in the periodic table, we see as the number of electrons, the number of electrons is equal to the number of protons is same. So that is called your atomic number. So atomic number will decide how many electrons are there in each is there in an atom, and then that way we could classify atoms into different classify that into a periodic table on the basis of the atomic number, but not on the basis of your atomic masses. So we did that in the basis of your atomic number. So those atomic number is nothing but is given by this principal quantum number. Okay, so these are called your orbits. Now an electron can move in one energy level to any another energy level, or the quantum or the photon jumps only when it resides in an orbit. It is the lowest state or the ground state. So we all, when the reaction happens, like when one thing reacts with the other thing, the electron of the one subshell goes to the electron of the other subshell. When we talk about energy, when we give energy to the system, that means those electron which was residing in the subshell, when one subshell is in the lowest energy state, but once it get energy, it can also go to the higher transition state, higher energy cells. Okay, so that process also explains the color of the complexes, different colors of the complexes which we have, or different colors of different chemical substances, why it is happening. So these things are explained by these kind of this kind of principle, that energy can be shifted, electron can absorb energy, go to the next level. Okay, now it can jump from the low energy to the higher energy level, absorbing energy. Here at a high energy level, it is called the excited state. Okay, so this way it was going on. Then Maxwell came